So Mr. Zondi's touched on a few very relevant points that we will be revisiting during this presentation. If you look at military aerospace training and strategy, the typical view of national security in the past, 20, 30 years ago during the Cold War, has been we consider military might, military power as the sole measure of the country's national security. Subsequently, there's been significant change in how we view national security. It's not just how many submarines, how many tanks, how many fighter jets you have. It's also about social, economic, environmental, and energy security. So what this does mean is that military budgets traditionally reserved for military hardware is now competing with the other priorities. And this is a worldwide shift. So military budgets remain constrained and in actual fact are declining in absolute terms. The changing nature of the threat is a reality. It's no longer conventional warfare. It's non-conventional, it's asymmetric, innovative. I promise you we didn't miss this. Also the availability of technology, information, skills and experience. People, resources, competence is mobile. People move across the globe, people present at conferences, people publish. People are not necessarily tied to their country of birth, they are moving around. Knowledge, technology is mobile and is available. The Defence Review captures much of what is the national strategy on responding to this threat environment. I'm not going to speak too much on the Defence Review. In terms of how the battle space or the airspace has changed, if you consider something about 100 years ago, this is what the airspace looked like. There was the air system that was required to deliver a weapons payload onto a target. So we had pilot, no co-pilot, we had 2 guns, and the workload on the pilot was significantly less than what we see today. Even this photograph of what the battle space is probably outdated. But if this is a conventional airspace, and this is what we're looking at today in terms of platform, we have got a significantly more chaotic, more multi-entity engagement in a battle scenario. And the system that is engaging in the scenario is much more complex as well. If you look at Defence Review briefly, as Mr. Zondi pointed out, is science and technology we want major power bases for the future South African states. We're looking at force multipliers, how we exploit technology, how we use reduced acquisition cycles to acquire technology, using commercial off-the-shelf technology and partnerships as well. How we get smarter at buying equipment, and how do we partner to produce those technologies. So, if you consider modeling and simulation, I almost like to refer to it as a canvas for experimentation and innovation. And I will give due credit also to Command, Control and Information Warfare Group, and I've got my colleague sitting down. Because of the multidimensional nature of warfare, we cannot, as for example in aeronautics research group, by ourselves construct a battle space. You require multiple specialists in multiple areas collaborating on that. What is modeling and simulation? Mathematical representation of reality. So this next 20 minutes we are talking about how we use modeling and simulation to understand the problem space, such that we can derive the right solutions and the right problems. So we're focusing on understanding the problem very well. You can easily develop the wrong solution for the wrong problem, but we're looking at understanding the problem. So in terms of modeling and simulation, it's mathematical representation of reality. We want the appropriate level of fidelity. So we want a representation of reality that's fast enough but accurate enough. These are the two contradictory terms. You can have something extremely accurate but extremely slow. We are looking for the right balance between accuracy and speed. We want multiple entities. We don't want one aeroplane flight simulator. We're not looking for that. We're looking at multiple entities. And then the computational load goes on. How do we include as many entities as possible, but with enough accuracy. Unpredictable, emergent. We can't predict what will happen in an environment with a number of entities. And what modeling and simulation does is it provides a platform which you can understand this. You have a better chance of understanding it. You immerse a number of entities, you model a number of entities with properties you understand very well. And you observe this experiment unfold as time goes on. We're looking at modeling and simulation for tactics, doctrine, evaluation, and development, for training, for acquisition, for operations planning and innovation. What properties, what performance, what sub-technology should your solution have to solve the problem of the battle space? It's very critical to understand, given that we have constrained budgets, given that we have constraints on time, what are the levers to solving the problem? So we urgently need to understand what the drivers of mission success are. We don't want to do one scenario, we want to do thousands of scenarios. Not one battle space engagement, we do thousands of battle space engagements, multiple entities to understand as much as possible what the drivers for mission success are. And so modeling and simulation provides this canvas for collaboration, for experimentation, for analysis, and understanding what systems we should procure, what systems we should develop, and what technology we should focus on. I did show you this screen earlier on, for those who haven't seen it. So this is typically what you would like to see in a modeling and simulation environment. The ability to track multiple entities, engaging in multiple scenarios. And we want to do this faster than real time. We want to prepare as much in the computer environment, understand as much in the computer environment before we engage in an actual experiment. And together with Command and Control Information Warfare, we have this ongoing effort to enhance our use of modeling and simulation to understand the battle space. So in an environment like this, you can use this very, very powerful tool to enable the commander to understand how we build a concept of operations, how we train, how we prepare for it. So this is not really modeling and simulation, it is a real-time tracking of an experiment actually. So in this environment, if you just use this analogy, you can simulate the subsystems like sensors. You can simulate some behavior of the pilot. I don't think you can understand all the behavior of the pilot, but we can try. We can understand what the impact of terrain is, what the impact of the environment is, the impact of threat systems, particular performance on threat systems. Understand this. So what we at the CSIR have done is developed this in-house mission simulation framework, which we can develop mathematical representations of systems, including human systems. And what we could do is we could run these thousands of simulations. So what I'm showing you here is a very simple constructed simulation. What we've got is a tracking radar and various ground-based units within a particular area. And what you will see is a dome over the entire area that's coming up. So that dome represents the range of the weapon systems that will be launched by those ground-based units. And so the tracking radar picks up the incoming aircraft. So we can code the tracking radar properties into this environment. And what the computer systems on those ground stations will do is say, okay, at this particular approach speed, we should try and fire our anti-or air defense system at the right time, such that when the planes enter the engagement zone, we won't run out of range in the sound system. So this is just to give you an idea of what that particular scenario is and what this particular tool is capable of. I did speak about UAVs earlier, and I don't think I want to go too much into it. But for the benefit of those who haven't been in the earlier session, once again, the cost of UAVs is not cheap, especially military systems. And we would like to understand the difficult questions like how we engage, how we insert a UAV into a theatre of operations. What is the command and control like? What properties should that UAV system have? What sensor performance should be in place? And how do we train for that? So without much ado, I think I'm going to help you with the time. But that's all I have to say.
Thank you.